Okay, well, welcome to Science Sunday. Thank you for coming. As you know, it's usually the second Sunday of the month. The next one, though, will not be second Sunday of June for various reasons. It's going to be on May 31st, which is in 3 weeks' time. Okay, and that's going to be about science and symphony with beautiful science symphony demonstrations. And today we're happy to have back Arthur Nicewick, who, back by popular demand, last Sunday, Science Sunday, he talked about AI and the cloud. He didn't quite get to the cloud, and he maybe wants to say more about AI. So he's back by popular demand, and I've forgotten exactly what his accomplishments, but he's going to introduce himself. Thank you, Art. Okay.
Thank you.
And please wait for the microphone if you have a question to ask.
All right.
I walked in Monday feeling so small. My laptop cried, please don't upload it all.
And he wants to start with a question.
I wanted to start with a question because you just said something I didn't understand, and I'm sure it was a joke, and I love jokes.
I'm sorry?
Tell me why you said that about convertibles.
Oh, it's not that funny. Some people, you got to look at the positive side of the cloud. There's a lot of great things in the cloud. We'll be learning more about them. And I was just referencing to the idea that sunny days are great, but clouds are good too. So that was
Get the joke.
It was a joke. Wasn't that bad? All right. So talking about the cloud, I went ahead this morning. I was playing around and I decided to get a little. I want to do a little song for intro, so I made a song. Can you guys hear this? What? Okay, I guess we'll just. You know what? We'll try doing that. I can try doing that later. Let's just go ahead and do the presentation. Sometimes things work, sometimes they don't. So we're here to talk about cloud computing. I guess I need the microphone for the recording, right? All right. So we're going to talk about cloud computing. Does anybody? What have you heard about cloud computing? What do you guys think it is? Up in the sky. Go ahead.
All my data is on the cloud.
All my data is in the cloud. Yeah, that's one very common thought. Someone else's computer. That's a good one too. These are very common ideas.
It uses a lot of energy.
It could use a lot of energy depending on what it's doing. Yes.
In County, I saw this huge data center, and somebody told me that's where the cloud is.
Yep.
In that huge data center.
75% of emails go through Loudoun County in the world. Now there is a person, David, is David here? David Namimi? No, you're right in front. David worked for a company called Network Solutions. VeriSign. Oh, you work for VeriSign. Well, VeriSign is very similar too. They bought Network Solutions. Originally, Network Solutions was the spot that all of the URLs in the world went through. And it was just right here off of Reston. We're kind of here in Virginia, we're very much the hub, the center. There's a lot of things people think California is the center of technology. That might be the center for innovation, but the center for connectivity and cloud computing is basically Loudoun, Fairfax, Virginia. We are the center of the world for that. We're it. And so when you talk about data centers, that's us. That's not somewhere else in the world. We are the center. Because the DoD is here, and because the federal government is here, when it came time to set up the internet, they built all of these cables, and they all needed these cables with redundant, multiple cables, redundant cables, and they all went through the Washington, D.C. area. So connectivity to this Washington, D.C. area, basically originally because of the military, but then onwards for other agencies and stuff, was essential when we were building the internet. And when people started saying, where do I want to put my big hubs and data centers, this became the spot. If you look at a company like Amazon Web Services, that's one of the biggest data center hubs in the world. And they basically, if you look at their map and how they run data centers, we have 6 what they call data center complexes. They call them availability zones. But we have 6 data center complexes in Virginia. Nowhere else in the world do they have 6. They have 3 on average, or less than 3. So we are like double anywhere else. And then we have 6, plus we have data centers for the government, which are separate, a separate set of wires. Data centers for the CIA, intelligence, separate set of wires. So one thing, you know, when you look at the internet, which is hard to understand, the internet is set up with being all these wires set up around the world, you know, just all connected. But then when it comes to the DoD, they don't use the same wires. They have another set of wires. It's called NIPRNet, is the name of it. And those wires connect to the government installations and to the military. And if you're the CIA, they have SIPRNet, secret internet protocol. That's another set of wires, another set of fiber optics. They don't cross. So if someone can't go into the internet and get into a secret machine because it's physically separate wires, separate fiber optic cables. But all of them come through here, Loudoun, Virginia, Fairfax, Virginia, and we have all of the data centers here. So we are, and you are living in the center of this universe. So let's get a little history of what this is all about. Years ago, I mean, it's an amazing revolution. Hopefully you'll understand why this is a fantastic thing. Back in the days, people were setting up the internet. Now, when I started in computer programming, I would be up on the 4th floor of some building, and then they move us to the basement, and I'd be coding in systems in the basement of these buildings, and then the computer room would be around the corner, and they would have these big old mainframe computers, multi-million-dollar mainframe computers. If you wanted to have a system, you'd have to buy a multi-million-dollar mainframe computer. If you wanted to invent software, you would have to buy a multi-million-dollar mainframe computer. And who could do that? Well, maybe, you know, big companies, you know, government institutions. But people, average good Joes, average people, no, we couldn't do it. We couldn't do that at all. Then the evolution came with what they call the commodity computing innovation, where all of a sudden all these smaller boxes came in. The smaller boxes were great, but they fell apart, they broke, they weren't as reliable. And then people would come over and they would have a closet like this picture here full of servers, and somebody would say, oh, I'm vacuuming the floor. They would unplug the servers and they plug in the vacuum cleaner, and then the internet would go down for that installation. That common thing happened all the time. It ran too hot, it got equipment, the room turned off, the heat went out, the cooling systems didn't work, they broke down all the time. So also, if you're a competitor and you want to shut down your competitor, what do? You go and find out what closet they are, or maybe, you know, knock out a power supply or a line into that building. A lot of problems. So you had to get guards to stand and watch this stuff. You have to hire guards, and you have to make sure that you had 2 power supplies in case one power source went out, and 2 sources of electricity in case one went out, or 2 internet connectivity in case one went out, you had another one. This was all very, very hard to do. So an innovation came along years ago called co-location, or we often call this application service providers, or ISPs. This was a big move, probably, I'd say late 80s, 90s, 1990s. And what you would do is you would buy a cage. You would go into this warehouse, and the warehouse had security guards, and the warehouse had multiple power supplies, and the warehouse had a slanted roof so the snow didn't crash into it, and the warehouse had multiple, you know, had all this stuff set up. And you would buy a cage like this. This is what they look like. And then you would go into that cage and you would put your computers in there. And then the cage would have connectivity to the internet, and you would plug it in, and you would have your computers running in there. So instead of running the computers in your basement, you ran them in a cage at these application service providers. And this was a very successful business. And it was very popular here in Loudoun, Virginia. It was a common thing. I've gone to them and I worked in them. I'm sure David's probably seen some of them. It's very common back in the day. You got a key. You went in there when you wanted to change things. You would bring in your floppy disk and put in new software, and that's how it worked. And everything was great, but it was expensive to run. Then this thing came along. It'd been around for a long time, called virtualization. It's a big word. It's confusing. But it suddenly was this idea that instead of having this cage with your computer in it, we'd have a giant computer and you would buy a part of a giant computer. Now, the way that worked is they said, here is a big physical computer, physical meaning metal, you know, but we're going to take that physical computer and using software, we're going to create little virtual subcomputers. And each one of those little virtual subcomputers became its own virtual computer that didn't know about any other computers. You had your own space, your own processing. So now you didn't buy a cage, you joined a common cage, a common computer, and you got your own little section. And this concept was called virtualization. It was very big, and it was a huge innovation. One of the big realities was that when the people had lots of small computers, the average utilization on those computers was about 17% utilization. So most of those times, those computers sat around doing absolutely nothing. And when people brought up new apps, they would say, new applications, they would be like, well, I don't want other people on my computer. I want my own computer. So they would put their own computer up there, and that would use 5% of that one. And then another 5. So suddenly you had hundreds of computers, each one having one app, maybe two. And sometimes people would say, you know what? We're wasting our computers. We want to share computers. So two people would use the same computer. But then, and this happened to me a lot back in the day, someone would come along and say, oh, I want to upgrade something for my system, and they didn't tell me about the other system, and they would break my system because you're sharing. Two people are sharing the same room. It was a nightmare, but virtualization solved that by saying, we'll just give everybody their own little pieces and share. So, you know, if you think of it the old way, we had a house, you had everybody, and you had your 17% utilization. But, you know, it was just one person. You got the whole thing for yourself. It was mostly empty. Everybody got this one little part, and most of your room, most of your house was empty. And you were like, why? Why am I doing this? And this was a waste. But with virtualization, we're looking at like we're looking at a hotel. We're looking at an apartment rental. People could come along and say, oh, room 2301 is empty. I'm going to rent that out for a day. I'm going to start using different parts of that hotel. So instead of houses, we moved to hotels. And now you optimize how big of a room you need in the hotel, how many beds you need, what amenities you need based on what you want. And you paid different prices for the right of hotel room that you wanted for that night. And this is what virtualization became, this idea that you could buy a little bit of a big part, kind of like buying a hotel. Well, this was a great innovation. It allowed people now to say, hey, I don't have to buy a giant computer. I could just take a little piece of a bigger computer and save a lot of money. And when I stop needing it, I could just get out of I could check out, just like I could check out of a hotel. Imagine what the world was before there were hotels. You know, what would happen? You would go to some place, you'd have to buy a house to spend the night in Phoenix, or you would have to sleep outside, or basically just not go. So the innovation of the hotel, which were virtual homes, was a great innovation, but we don't see that way. It's what it was. But what was the problem? The problem was with the ASPs, the old co-location facilities, is that when I wanted one of these hotel rooms, I couldn't go online on the Travelocity and just book it. I had to go over to the owner, and I'm going to rent it for 6 months, and sign the paperwork, and it made it hard. So someone came along and said, all right, you know what, we're going to hook up these hotel rooms, we're going to hook up these virtual little servers so that you could just go to a vending machine without anybody around. You put in your credit card, you don't have to go anywhere, you could just stay on the internet, and you could say, I want a little server. And it will create a server in this data center, which is a virtual server, and just let me use it, and I pay for it. So it's like a server in the cloud. Someone else's machine, I push a button, I get a server, and it's all mine. I put in my credit card, I push a button, I want a server. Okay, here it is. Here's your IP address, here's your credentials, here's how you log on to it. You now have a server. What do I want to do with it? I want to install Microsoft Office. I want to install a database. I want to build something. But you have a server now. Now, why is this such a big deal? Remember, in the olden days, if I wanted to build an application, if I wanted to server, I had to build, I couldn't do it myself. I had to go and build a server room. I had to build a buy a mainframe. Now, I could sit in my house, in my living room, and say, I want 50 servers. Push a button, if I have the money, put it on my credit card, and now I could build out a giant complex for me to use. As many servers as I want, as many servers as I'm willing to pay for. In the old days, the only one who could, you had to buy these things and bring them in, install them, and set them all up. I can now just go with my credit card, push, 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 and it looks like this. Here's the console. I click in there. It says, here are your options you have. I select what area of the, I select, you see it says AP South there. That's like what building do you want to put the server in? I click on one of these buttons. It says I'll put a server in there. I'll put a database server in there. I'll put a backup server in there. I'll do anything you want. You just click the buttons, and I'll create that for you. And I'll give you the IP address of where it exists. I'll give you the credentials, so you're the only one that can use it. It'll be on the internet, and now the world can use that device. This is amazing. Now, no longer is IBM, no longer is Exxon, no longer does the federal government the only ones who could build and create systems. Now anybody can. I can do it. I can build up. If I have a good idea, I don't have to work for a big company. The cloud, I could just go there and create whatever I want. And it'll let me do it. And so it's a miracle. So it's really amazing. And it created a lot of innovation. And also, it created experimentation. A lot of companies said, you go to your boss and you say, listen, I need 40 servers to build some big database which is going to help me analyze the cure for cancer. And someone said, how many servers? And you go, I need 100 servers. They go, well, 100 servers, that's going to cost you $2 million. How long do you need them for? And you go, 3 weeks. Well, you can't buy servers for 3 weeks. We'd have to buy them and set up a room and get a guard and get air conditioning and expand them. It'll cost us $10 million to put those servers in. And then you say, no, I'm going to buy them in the cloud. I'm going to use them for a week. And if we don't like them, we turn them off and we stop paying. Now you could try something, and if it fails, the cost is minimal. So this allowed people to try new ideas, try innovation without committing to these large capital expenditures of buying this equipment. You don't have to buy anything anymore. Just use the stuff in the cloud. So it was really great for experimentation. It was great for workloads that were like big for one day a year. It was a lot of stuff like that. Well, what happened is when it came time to get these things, I'm going to switch this again. Try it now? All right. I need to move more. I bounce around a lot. So when it, so the NIST, so what happened was now the federal people started talking, and what ends up happening a lot is people will say, they'll say, okay, what are we going to call this thing? We need a name for it. We got this application service providers, and they send up cages and they put things in there, and we need to come up with a name for this thing. So we have to come up with some creative idea. And is it different from application service providers? They had the cages. Why would this be different? So we started looking for a name, and if you were in computer science, you used to draw out what they call network diagrams. So this is a traditional network diagram we have here with all the servers and wires and all that kind of stuff. And then all of a sudden, you see on the bottom there, you see that little thing that says internet in it? Let's zoom in on that. That there was a cloud. We used to draw clouds on our diagrams. And usually when we went to the cloud, we're not going to draw the whole internet. We just drew a picture of a cloud. Sometimes we put David Niemi's face in it. But basically, it was a billion computers all hooked up. We're not going to draw a billion computers all hooked up. We're just going to draw a picture of a cloud. And that was what we did when we drew these internet diagrams. Well, these guys came along and they saw that we did this and they said, hey, we need a name for this paradigm. Let's call it the cloud. So they're off, the person who's doing this off screen. We're going to take that little cloud image, it's on the bottom of the network diagrams, and we're going to co-opt that. So we're going to say, we're the cloud. That the cloud is this idea of this server which dispatches virtualized containers or portions out to the world. Well, NIST, as I brought up before, looked at that and said, you know, that's a good name, but we got a name now. We need to kind of describe what that thing is so that when people say they're buying things, they could actually be clear about it. So they came up with a definition of what the cloud was. So first thing they did, they just said every cloud must have these 5 characteristics. So as I talked about before, this is that on-demand self-service. You must be able to go in with a credit card. You don't have to drive anywhere. You don't have to call anybody. You should be able to go to the internet without talking to anyone and just put in a credit card and purchase it. That is a requirement. If you can't do that, that's not a cloud. Now, these rules bend, you know. If you're going to buy a whole building, you might have to meet somebody. But generally, that's the idea. A cloud should not just be for one little area. It should be for a large area, like the whole world. Because if you put your stuff in the cloud, you want to be able to do business with people in India and everywhere in the world. So you want to say, if I put it in the cloud, it's broad network access. It's not just a local area network. It's the full internet. That's a requirement. That's what parts of the cloud is. Resource pooling is the same term for virtualization. You don't put your own servers in there. You share. You pool resources. You share the resources. That's part of what the cloud is. Now, these rules break here and there, but generally this is the rule. Rapid elasticity. That is probably the most fascinating one. So I can go into the cloud and imagine this. I buy a server, and a server might cost me, say, about 60 cents an hour, one server. About right. Depending on how big it is and how many CPUs and all that kind of stuff. So let's say I put my website up and I run one server for 60 cents an hour. Then I decide, well, it gets really busy sometimes. So I'm going to put up sometimes, like I'm going to put up my payroll system. And on Fridays, everybody puts in their timesheets. But on Sunday nights, nobody's doing anything. And on Monday nights, no one's doing anything. So only time I need a lot of computers is on Friday when people do their timesheets. So what I'm going to do is I'm going to say, I want one computer to run all the time, but on Fridays, I want you automatically expand to 10 computers for that one day. Or I could say, if I see it's getting busy, if I see lots of people are coming, I have a sale on tennis shoes, and all of a sudden, or I have tickets to Mick Jagger concert or something like that, and all of a sudden I see thousands of people jumping online, I automatically will start adding computers. Now they'll pay for them as they come on, but then after, you know, the Mick Jagger sales are over and everything's sold out, all those servers go away. And I stop paying for them. So that means, I mean, you know, did a lot of work with the DoD, and in the DoD we'd say, look, when it's not war, when we're not in the terms of a battle, we don't need any computers. Just give me the absolute minimum because I want to save money. But when we need thousands of computers because we're, you know, or it's Black Friday for Walmart or something like that, or it's, you know, some holiday or all the people are coming to shop, I need lots of computers, but I don't want them all the time. So this idea that I could expand out when I need it and shrink back when I don't, That's part of that whole virtualization. That's part of sharing. And that's part of the requirement of what the cloud gives you. You don't buy computers and you're stuck with them. You can let them increase and decrease automatically. That's what we call rapid elasticity. And then the fact that you're doing all this means you're going to have to pay for it. You're going to have some way to measure how much you're paying for. So that's the last of the 5 characteristics as defined by the National Institute of Science and Technology. Also, they have several ways to store it. We have this shared space, which is public, which was you're probably used to. Then we have your own secure place, which is what the government might do. They're going to say, we want to have a cloud, but we only want the government, we only want the CIA on that cloud, nobody else. We only want federal institutions. The police force has their own building, their own wires, their own connectivity, and they'll have terms that say, we will hire people who are cleared, who have gone through security clearance. They're not allowed in the building unless they have that security clearance to get in that building. The servers you can't share if you're certain types of data. You know, they're very serious about that. If there's a police, say I'm going to do an investigation because of some kind of incident, they can come in there. The servers are constructed in such a way that you won't accidentally be revealing other people's data when they pull your server and start scanning it because this other server, who just happened to be on your same box, was similar. So all of these kind of rules take place when you start getting into your own space, your own cloud, and that's for security reasons. Also, what you could do, and a lot of people do this, is they'll have a little cloud in their company, and then they'll say, everything's great, but when I run out of speed, when I get to the problem, when I get to the point where I am running out of computers, I want the system to automatically jump to the cloud and start using cloud resources. So I'll pay for that one computer running all the time. I won't pay for it, I'll just have my own computer sitting in my closet. But when I need 50 computers because it's, you know, Black Friday, it will automatically expand out to the cloud and start using all those cloud resources. So you could have it switch and share between different groups. Shared interest, well, shared interest is also, so secure place would be more like CIA, and shared interest would be more like the government cloud. So the police force and the federal government and school systems are all on a shared one with higher levels of security. Now, this is where a lot of people are very confused about the cloud. This is probably the most important thing. If I ask you, tell me what a vehicle does, you would say a vehicle, oh, it has 4 wheels. And I say, does a helicopter have 4 wheels? And then you say, oh, okay. Well, a vehicle, you park it on. No, does a boat? Is a boat a vehicle? Yeah, a boat's a vehicle. I mean, there are lots of vehicles, but we don't, when we say cloud, we're really talking about different things at times, just like helicopters, cars, vehicles, buses. They're all vehicles, but they're different. So there's 3 types of clouds, just like there's many types of vehicles. The cloud that you're probably most familiar with is, see that one that says fully cooked solution at the end? That's software as a service. That's Netflix. That's Gmail. I'm going to go there, and I want to go to the cloud, and I'm going to use Gmail to do my emails. And that is software as a service, and that is a type of cloud deployment where you can go over there. You don't have to even buy anything from Amazon. You're just going to Gmail. That is called a cloud. It's confusing people because they get mixed up together. The one in the middle is called like renting a kitchen, and that's going to be called platform as a service. This might be a backup service where you back your stuff into the cloud, or a database service where you're using a service which the cloud offers. It's not an application like Netflix or Gmail, but it's like I'm going to do backup into the cloud, or I need a database in the cloud, or I need a VeriSign facility to check my validation of my security in the cloud. These would be called platforms that you're using in the cloud, or platform as a service, or PaaS, P-A-A-S. And then the last one, I'm doing in reverse order, is when you rent the building, when you're renting the foundation, and that's called infrastructure as a service. And that's when you hear people saying, I want a server. I don't want you to give me a backup system. I want you to give me a box and a user ID, just like you went to Best Buy and bought a laptop. Now I want you to do the exact same thing, but I want you to do it over the internet, and I want that to be housed in the internet. And that's called infrastructure as a service, and that's very common too. So if a big business might say, I need 50 servers, they're going to go out and get infrastructure as a service. If you want Salesforce to be able to do your customer relationships, you would do software as a service. If you need a big backup system or you need to use some type of backup service, you would do platform as a service. What is the most popular software as a service out there, you think? I'll give you a hint. It has to do with the number of days in the year. What? Office 365. Microsoft Office 365, the software as a service platform, is probably one of the most popular and biggest out there. Everybody uses it. It's software that you automatically pull down. So we have those three things: renting a foundation, which is renting a server; renting a chef's kitchen, which is like renting a database; and then renting a fully served solution. It's like using Gmail. And those three things are all considered cloud. So this is where you get a lot of confusion, where people say, oh, I use the cloud because I go to my iPhone, updates data to the cloud. Yeah, that's true, just like your car drives you to the cloud. But helicopters are vehicles too. And jet planes and spaceships are vehicles too. You can't just say that you know a vehicle because you know of one type of vehicle. And yes, iCloud, loading databases, doing backups into the cloud is one type of cloud offering, but definitely not the only one. Mostly when the government talks about the data centers, they're talking about the IaaS, the first one. When consumers, like people on the street, talk about the cloud, they're usually talking about backups, like soft platform as a service, or they don't even know they're talking about the cloud when they talk about Gmail and Netflix. They're talking about the cloud. They don't even know it's the cloud. They just think it's a system. So where are the clouds? So is the clouds below that word or above that word? Notice the no windows. You don't need windows if all it is servers. Yep, there are lots and lots of these. As a matter of fact, 70% of the worldwide email traffic. We are living in Ashburn, Virginia. We live near Ashburn, Virginia. We are called Data Center Alley. We have more data centers than anywhere in the world, basically because of all that telecommunications lines that came here because of the government. We are the center of the world. 70%, sorry for the cutoff there, 70% of the world email traffic goes through Loudoun, Virginia. Probably goes through Dave's software program that he wrote. So that's a lot. I mean, that's running the whole world. That's a big deal. We're the place. Everything. Check your, if Gmail, Netflix, all that stuff is right here. We have all of it. We're the center of the world. We're the center of the brain. It's kind of scary in some ways. And everywhere else. I mean, they set up cloud facilities, those big buildings with no windows, all over the world. And that's Microsoft has them, Amazon has them, Google has them, Oracle has them. They're all over. And there's other ones, DigitalOcean, lots of them. So there are many, many of these cloud facilities everywhere, all over the world. And each one of them is a different building, and you could have your things shared and propagated across everywhere. So the cloud is disruptive in a good way. It means that before, if I wanted to build a computer system, I couldn't do it unless I worked for Exxon or unless I worked for some government agency who had the mainframe in the basement, and then I had to share the time, and I couldn't afford it. That's the old. I was not able, as a regular person, to build a system and share it and put my website out there for the world to use. That was not possible. It was something that we take for granted, that we have now enabled an average person, a kid in the ghetto, anybody in the world, to be able to create a data center as big as the biggest ones that exist. Well, not as big as, some of these guys own their stuff, but as big as a large company. You know, that capability never existed. We have something which is equalized the world. Equalized people in Africa, people in China, people in everywhere now can say, I want a server room. All I got to do is just connect and pay. If I get the money, I could pay for it. If I have the good idea, if I have the good idea, then let me do it. And that's true. So that way it was a great. Now, I make this comment there about Lambda. Lambda, I kind of had a special piece of my heart for this one. Lambda is an offering to the cloud. It's not super popular, but it's an offering of the cloud that says, you pay nothing until someone uses it. So there's these companies that go out there, it's very common, and they'll create this complex to have 1,000 servers that might do, like this, here's a real example, okay? There's a company called, it's A Cloud Guru is the name of the company. And what they did is you would go there and they would say, I want a video on how clouds work, okay? And you would give it the name of the video that you want, and then we go search for it, and then we do is analyze it and pull up all these video things and then serve it to you. Well, what they did is they said, we're going to store all the videos on a disk out there, but we're going to have no servers. We're going to pay zero for any kind of equipment. If somebody asks for a video, we'll run to an existing server, say, hey, we want to spend a little bit of money and get that equipment, get that video file out and send to a client. It would be like 1/10 of a penny, something like that. And then that video would show up for that person. If nobody came to their site, they paid nothing. So if you had an idea and you put it out there and it was a bomb, it was a failure of an idea and no one used it, you paid zero. So it allowed you to take chances. It allows you to experiment with an idea and you pay nothing unless it's popular. If it becomes popular and people start using it, you'll start paying. But now what does that mean? That means that you could take risks. You could take chances and you have a low probability of failure because you only have to pay if you win. I mean, think about it. Imagine that you could buy a lottery ticket and that you only have to pay for the lotto ticket if it's a winner. I mean, yay, right? So that was a great paradigm. And that's called Lambda. So some of these things allows an average guy on the street, that allows a kid in Africa to build something who doesn't have a nickel to his name, but he could build his infrastructure. So that's a good thing. How about the bad thing? Is cloud bad? Yeah, cloud's going to be bad. I mean, a lot of people say the security of the cloud is better. Some people say, well, if you put all your data in some place outside of your building, if you're putting all your data in someone else's building, you got to be afraid. So that's real. And you have to really, and there's a lot of controls on this, and that's something you just got to recognize. And that's part of the reality. Remember I said the cloud is like a hotel room, or the cloud is like a rental car, you're renting it? So imagine if you lived in a hotel room. Imagine you decided that you don't want to have a house, or you don't even want to rent an apartment, you want to live in a hotel room. You're going to spend a lot of money. So it could cost you a whole lot more. You have to be wise. There's tricks on how you do this so you don't pay what you can. You could go with that Lambda serverless thing so you only use it when you need it. But it can be very, very expensive. So you got to be cautious, and a lot of people aren't. They set up the thing and they walk away, and all of a sudden they get a bill for thousands of dollars, and they're like, what happened? And that happens all the time. So it's very dangerous. We're worried about this one. This is the one that everybody's talking about now. So the energy use on these things is getting really high. Okay? And there's really a lot to do here with the next bullet point. I'm going to jump to the next one, and then I'll come back to this one. What's happening is artificial intelligence. We're seeing artificial intelligence. Again, remember the scenario where we're saying, I want to use 1,000 servers for 3 days, and then I want to stop. Well, where can I do that? Well, the cloud is the perfect place for doing that. But now what's happening is it's getting, the cloud providers are hosting all of these AI vendors, and they want to build the models because they want to be the first one that comes out with the new brain that's going to run the world, right? And help us all. There's a lot of positive things and some negative. And so they're using a lot of CPU power to get this done. And when you use the CPU power, you're using a lot of electricity. And when you're using, also, these machines get really, really hot. To get them to cool down, they have to pump water through the machines. 80% of the water that they pump through the machine becomes evaporated into the air. Comes down as rain later, right? Because water, we're still drinking dinosaur pee, right? Water doesn't go away; it just recycles. It's the same water that's always been here. But but yeah, a lot of water is being used up, and people are complaining. So we're seeing this is our big negative. We're seeing huge amounts of energy use, which is carbon footprint stuff, and there's a lot of legislation. And I think, and we talked about this last night. I have listened to a lot of legislation on this, and I have heard no disagreements, even from everybody, even including the company, even including Amazon and Microsoft and Google. Everybody agrees that these AI providers, they need to foot the bill. They need to pay for this electricity more than everybody else. So, the communities, some communities were getting their prices boosted. People started complaining, and then Microsoft and Amazon and all the politicians in the world from all sides of the spectrum all agree, hey, this money, the consumer who happens to live in Loudoun, Virginia, should not have to foot the bill for the world to use these AI machines. So they're taking it up. And as a matter of fact, a lot of the stuff that's going on right now with a lot of the data center build, the rule they said is if you want to build a data center, you also have to build a power plant. You can't suck off the grid and take away the people's power plant who lives there. You got to provide your own power. Do it solar, do it gas, do it electric, do it whatever you want, or not electric. But you got to build your own, and that's. So we're seeing a lot of resurgences of technologies such as nuclear, which is coming back now. We're seeing a lot of the saltwater reactors, which are fairly safe. A lot of that stuff's being innovated now, not just by the government, but by the data centers, and hopefully that'll bring a lot of new things. So we're right now in a transition time. We live in Data Center Alley, so if anybody's going to get hit by the increase of electricity prices, it's going to be us. And if legislation's going to do something about it, they'll make sure we don't get stuck with the bill. Hopefully, we'll find out. So yeah, electricity is a real big problem, and they're using a lot of the electricity, and cooling is a really big problem. They're using a lot of water. They're switching now to using sewage. Instead of fresh water, they're going to try to use sewage water, dirty water. They're trying to use contained, they do evaporative systems now so that they can actually recycle the water, but 80% of it still goes into cooling, or evaporates into the sky. So, and then even when you do that, you can only do it for so long before it like crystallizes, and you have to flush the whole system and put new water in. So they have closed loop systems that they're working on now. They're trying it. Innovation's taking place. We'll see how it goes. But water is a lot. Right now, they're still using a lot of water. Hopefully, that's a problem that'll be solved. So that's about it. So what do people think about this cloud thing? All right.
Questions. I really have one comment and a question. So these talks, as you may know, are all on YouTube, and if you go to the church website, you can go down and find them, and I presume that means they're all stored in the cloud, right? YouTube talks? That's right. That's right, okay.
Okay.
Ruth.
So we know that the data centers are in Ashburn, and my question is, why does it have to be here if it's the data's coming from all over the world? Why does it have to be here? Why can't it be in the Arizona desert or something?
This is where the big fiber optics cables converge.
Oh.
Because of the government. We buried all the cables here. All this, and also you have the DoD cables and the federal cables and the CIA cables, they're all here.
Okay, my daughter and my husband have a running argument. She says we should use a password manager, this one she suggests. He says, no, we have a server at home, it's safer to use our server. What is your thought?
What, do I think the cloud is safer than the server at home?
Yeah, for password management.
For password management, this is going to be like religion, depending on how well you maintain your password. Some people who are super anal about keeping that stuff really clean, probably it's better to do it themselves. If you're a little lazier and you want to, like for example, when you save a piece of data in the cloud, it's kind of fascinating. When you save a piece of data, there's a service in Amazon called S3, Simple Storage Service, and Simple Storage Service, SSS, S3. And when you save something in S3, you save it, and it'll save it to this disk on this building in Ashburn. And before you get the response, it'll also save it in another building 30 miles away in another server, just to make sure you don't lose it. Then it comes back and says, I've saved it. Then it goes off and goes to a third building 30 or 40 miles away and saves a third version of it off in Spotsylvania. So one time you do a save, you're actually saving it in 3 buildings, each building is 30 miles apart. So these are called availability zones. So if this building gets in a fire, or if you get an earthquake, or if you get bombed, or whatever, you have 3 copies of your information. So that's the default. And one of the things which was really good about the cloud is, when I used to build systems, we wanted to build a disaster recovery, which means that if you get a 9/11 kind of thing, you don't want to lose all your data. Back in the day, when I built systems, what that meant is you would set up your whole system, and then you would go and buy one of these ISPs or ASPs, you would buy a cage, and you would set up the whole system again inside that cage. And then twice a year, you would take all your staff, bring them into hotel rooms, you've probably done some of these drills, go off at a DR drill, and then bring up the whole system in these remote locations to make sure that if 9/11 building drops, you could bring it up 30 or 40 miles away. Usually only one. You only get one remote site. And that was millions of dollars to run this. Nowadays, you push a button. Do you want disaster recovery? Yes. And it spawns your application across 2 of the availability zones. That you don't have to test it. You do nothing. So some of that security, which now is really easy to do. I mean, it'll cost you more because you're running get 2 servers, but it's not going to cost you like we did in the old days. Most people did not do DR sites, and they should have. They just rolled the dice. They were just hopefully we're not going to get a flood and lose all our equipment or if we do, we'll go to backup tapes and maybe we'll lose 3 days worth of data. That was probably how it used to be. That's not probably. That's how it used to be. Now it's you actively. The site burns down, you don't even know it. It just moves to another site.
Yeah,
So I don't know if I answered your question, but the cloud is safer in some situations. In other situations, it's going to not be it's going to be your own. I can't tell you which religion to follow.
So I have a question. You had an internet bubble there.
Yeah.
The World Wide Web, which was initiated about 35 years ago to connect computer systems around the world using the internet. So what's the somehow relation? Was that a precursor to the cloud somehow?
Oh, 100%. The cloud really, the internet is, the HTTP and TCP/IP and a set of standards which allowed for interoperability. When the cloud came along, one of the things that made the cloud great was the fact that Tim Berners-Lee, your buddy, had developed a framework where all computers could talk to each other. Remember, back in the day when I was working on computers, we had Apple Talk, so Apple PCs could only talk to each other. We had SNA, SNA, which was only IBM computers could talk to each other. And then what came along is this thing called TCP/IP, which many of you probably heard about. And this was a standard which just said, this is going to work on this thing called the internet. And everybody dropped everything, and they all said, let's use this one. As a matter of fact, the standard, which also the ANSI standard, which is, I forgot her first name, but the person who's running the thing up on the right, she works for ANSI. That was the standard of how we talk and how the bits were made. We used to use a standard called EPSIDIC, as I used to use. All these interoperabilities used to exist where people couldn't talk to each other. The funniest thing I always see is when you watch the War of the Worlds. When you watch the War of the Worlds, the guy takes his CD and he plugs it into the alien spacecraft and he plants a virus in the alien spacecraft, right? I think to myself, oh, come on, you can't even do that between a PC and a mainframe on Earth. What's the probability you have the same code set between spaceship aliens, you know?
Okay, just a sec, hang on. You'll need the microphone. Can you hang on to the set? I just going to follow up to my World Wide Web. I'll come to you, David, but I want to give a plug for particle physics, because the World Wide Web was invented at CERN, the European Lab for Particle Physics, now worldwide, by Tim Berners-Lee, to enable collaborators in scientific projects to all share the same computer. So that's a plug for particle physics. David, now.
Yeah, I just wanted to comment a bit on how the internet came to be interoperable. Originally, as Art pointed out, there are quite a few different standards for mainframes and smaller computers to talk. But those companies that were doing things, including networking companies that worked with microcomputers like Novell and Microsoft, didn't come willingly to the internet. They had their own systems. There was NetWare, and there was something called NetBEUI that Microsoft invented that was really badly designed. And Microsoft eventually got to the point where their internal network was too big to work with the protocol they made up. And NetWare was better designed, but not as well as TCP/IP, which was designed to really scale up to something worldwide. And this all happened before what's called the World Wide Web was really very big, but all the proprietary interests had to come together because they didn't have anything that could scale the way the internet could. So the internet was really started in the early 70s in this area. And by the 1980s, there were a lot of networking companies like UUNet, which were around here. And the first major access point where a bunch of different companies and organizations got their servers together so they could all talk was in the Tyson's Corner area, and was called May East, and there was a May West out in California. And then a little later, an important year was 1993 when AOL decided to let its users get on the internet and exchange email with people already on the internet, and then things took off from there. And AOL, as some people would know, was located right in the data center area of Loudoun County, and that's why the center of gravity shifted from Fairfax County to Loudoun County, AOL. And at that point, it was way beyond the government's influence.
A lot of TCP/IP, and you can correct me if he knows it better than I. But a lot of TCP/IP, the folklore, at least that I understand it is that it allows for kind of like an MPLS. It allows for multiple packets. So if an enemy came by and destroyed the line, it would automatically detect it and take another line and another communication line. So the DoD really liked this because they wanted to have resilience in case someone blew up a teleline, not point to point. You would automatically find a new home, a new way. Go ahead.
I just wanted to correct you on the movie. So what the aliens did, it was the aliens' fault. They actually hacked the Earth satellites in the first place. We didn't hack into the alien systems. We hacked back into our satellites, and that's how we accessed them.
I thought he stuck a little disc into the.
Well, yeah, but they're doing it through the connection that the satellites made. That's what the character explained. Just as the aliens turned the satellites against us.
I need to refresh my history on what the aliens.
Are you guys talking about Independence Day?
Yeah.
Okay.
I'm waiting for this disclosure of UFOs so I can find out what really happened.
So Independence Day actually had a bit where, a cut bit from the thing where they explained that the internet was actually stolen from the recovered alien technology.
Oh,
okay. So, yeah.
And they cut that out of the movie.
Explains everything.
So it was
so the cloud is a UAP. UAP capable. All right, go ahead. I'm sorry.
Okay, I know there's a lot of redundancy built into the system, but is there any security concern about the fact that so much so many of these data centers and lines are in this area, just clustered together.
Yeah, that's that concept. I mean, every company's do it different, but that's the company I talked about called availability zones. Every building has to be 30 miles apart. And here, like if you save something, you'll save it automatically to 3, but you could have it spread across up to 6 here in America, in Loudoun County. Other places you only get 3. But yeah, so the resilience is higher here just because we have more availability zones. We have more places that we could, make duplicates of the same site in case of failures. And remember, so there's less resilience in the government systems because, public systems, we have lots of data centers because there's lots of us. Government systems, there's only 2 because they're separated off from the internet. They are in the NIPRNet or they're on the SIPRNet. They have their own wires, they have their own cables. They don't allow us to talk to them or them to talk to us, so they can't have as many. So that's what it is.
Larry.
When you drive by these data centers, what's the utilization of them?
What is what?
The utilization, like you were talking about.
Oh, yeah. That's a good question. I mean, I'm sure that.
I have 2.
Okay, one of the most fascinating concepts of what goes on in data centers, there's a thing called spot instances. David knows about these. Spot instances is what happens is this. It's kind of interesting. So let's say they're selling all their servers, right? And let's say it costs 60 cents an hour to use your servers. All of a sudden, what they're going to say is they're going to look out there, going to say, oh, wait, we've got 1,000 servers here that are not being used. So they put those 1,000 servers up for auction, for the hourly auction. And they say, you don't have to pay 60 cents an hour. You pay what you pay, and we'll let you bid. So the price may go down to 10 cents an hour, okay? So those 1,000 servers, all of a sudden, their price has dropped from 60 cents or $1 or $2 an hour, maybe to 30 cents or 10 cents an hour, okay? They have a rule that says that if someone comes along and is willing to pay full price, you got 2 minutes to get off that machine, and then we're taking it and giving it to the person who's paying full price. Well, there's a lot of people out there that are doing things like big, heavy analysis, like massive data engineering, these jobs that run for months, right, that are doing heavy analysis. And they'll wait until the price goes all the way down to a really low point, and then they jump in and start grabbing all those machines. And then if someone else says, I want the machine back, they save the state of where they are, and they say, give it back and go back to waiting until a cheap machine's available again. So a lot of these machines that are not being used, they will be used when their price goes down low enough. And then a lot of the big data miners or big data analytics companies will jump in and use them at the low price.
But still, they have a utilization factor. But you have to
well, then that's keeping the utilization up, because making sure that the machines that are too expensive and people won't pay for, they're going to, once they get to a low enough price, people will jump in and start paying for them.
For cooling, are any of them using geothermal?
Any of them using geothermal?
For cooling, for the cooling.
I don't know. That's an interesting question. That's called a spot instance.
Tom.
That concept.
Yes. How will the development of a supercomputer, of a molecular computer, affect all this?
So supercomputers, the Cray supercomputer and things like that, they were, as far as I know, and I was a little bit in that community at one point in time, but not so much anymore. David might know better than me. But as far as I'm aware, when I was working in that area, the supercomputers and then the massive computer clusters, which means like lots of thousands of small computers connected together, were kind of competing to see which one is the better deal. And I think
you might be talking about quantum computing.
Quantum computing is different.
No, that's what I mean. Yeah.
Oh, quantum computing is not a supercomputer. Okay, quantum computing is a different paradigm of computing. So quantum computers, you cannot run things like laptops. You cannot do things like that. If a traditional binary computer, if you wanted to like solve a problem, and let's say you had a keyboard, a piano that had 1 million keys on it, on a normal computer, the way you would solve that is you would go, let's say you wanted to find out which which key is broken on this giant piano. You know one key is bad. The way you would do it is you would go to the first key and you go bong, 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 and go until you hear bong, 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 bleh. Ah, that's the one. That's the bad key. Well, that would take, if it was 1 million different keys on that piano, it would take 500,000 on average. You just go test each one, right? The way quantum computing works is quantum computing says, if I have 1 million, I'm going to take a square root of 1 million. Well, let's say, which is going to be what, like 1,000? What is it? 1,000. So I'm going to take 1,000th of that million keys, which is 1,000 keys, and just go all of it at once. And I'm going to go, I think I heard a flat key, I'm not sure. Then I'm going to go to the next 1,000. So I'm going to do just 1,000 of them instead of 1 million constructions. And out of those thousands, I'm going to say this was the 1,000 that had the flat key. And then I'm going to go out of those 1,000, now let me look 1/10 of that is, whatever square root of 1,000 is. And then I'm going to narrow down and find that flat key. That's how quantum computers work. So they could do things like encryption, decrypt things. They could do things like giant databases to find unique things, but they can't run programs. And one instruction in a computer, a quantum computer, is like 1,000 times slower than a regular computer. So quantum computers only have very limited things they can do. They could do it way, way faster, but they could do so few things.
I think quantum computing is another Sunday talk coming up to do that.
Well, the quantum computing expert is right here. So, Michael, was that a good explanation, or is that?
Well, it's one explanation. Yeah, I think it's pretty good because exponential rather than.
Right.
But another way of thinking about it, I think about it. Normally, you have a linear, like 0 or 1, but in quantum, you have a plane. You have 2 dimensions, so you've got an amplitude and a phase, and that enables you to be much more powerful about that. But I'll take this as a last question because we should finish soon.
When you were talking about clouds for the government, that they are, that they have their own clouds, private. How about the LLMs, the large language models? Do they have their own copy of ChatGPT or cloud or?
Yeah, they would have to have now. Sorry, I don't know what's going on here. I got to turn. Let me just get this. Make sure this app goes away. There it is. Yeah, if you have a private cloud, you're going to have all the software yourself. So you're only going to be doing that with software that you own. If you do the private cloud, there's not that many private clouds. It's very uncommon. Now, a private cloud normally would be like I might have something in my own business. The big people that do private clouds are pharmaceuticals. So what a pharmaceutical would say is I have all of this data that is like about people. And I can't put it out on the public cloud because of legislation and laws. So I have to keep my data, housed on premise. I cannot put it out into the cloud because it's against the law because of HIPAA standards. So they keep all their data local, and they use a lot of private clouds. Yeah, they're going to be more like a SaaS offering, a software as a solution offering. So if you're doing... So you're actually correct. So like if the DoD was going to house a large language model, they actually have to take the large language model and put it in their own DoD cloud. And that was one of the problems because when I worked for the DoD and I used their clouds were like 2 years old. And you know how their large language models were like 2 years old. And 2 years in large language models is like, forever. So it was really bad because you couldn't, I'm sorry, okay.
Okay, let's...
Did you have one last question? Last question.
Really last one.
I apologize for disappointing you. It's not a question. It's an announcement.
Oh.
There are pieces of cake left in the lobby here. Please come out and take your share so that they're all gone.
Thank you, and thank Art.
And important announcement, Happy Mother's Day to any Mother's Day.
Happy Mother's Day. And next Science Sunday is in 3 weeks on March 31st. Thank you. Science and Symphony.